Here's a calendar. Today we're doing the section lab. So if you've not done any sectioning, that'll be new. And then you got to do it in AutoCAD. So that'll be even double new. So there's some things I need to cover to make sure you have that skill set. Let's talk about sectioning. So in week 3, under today, I put some examples so you'll be able to see that. Sectioning is basically slicing through an object. And the purpose is to get a view of the internal componentry of the object. So most of these we would not typically section because there's nothing very creative about what's inside the part, right? But they're good examples to get started. And that's what we're going to do also, is some pretty simple ones. After we do those, I'll bring in one that actually the only way you could actually see the inside of the part would be a section view. This is pretty good on the right here. Like that's a nice view that you're just not going to get from a right side view because all this geometry is going to be hidden and we cannot dimension to a hidden line, right? That's our rule. So this really helps dimensioning and it helps us to see the inside of a part. So to create a section view, let's just look at this first one, this rectangle here. To get a section view, and there's the plane that they're going to slice it with. That's what you have to decide, is how you want to slice the part. That's up to you, or I tell you, one or the other. If it goes fully through the part, it's a full section. If it only goes through a portion of the part, not all the way through it, then it's going to be a half section, which is kind of weird because this looks like half of the part, but it's not. That's a full section because the cutting plane, this cutting plane goes fully through the part. So that's a full section. That's a full section. This one's a full and this one's a full because they do go all the way through the part. Okay. So to create a section view, you're going to have a view of the part to put the cutting plane line. Like this one, they drew the top view and then they put the cutting plane line in. That's this line. So that is the same as these arrows and this line, right? This is the cut. So think of a knife cutting through the part. Then instead of a typical front view, we draw the section view. So we just remove the front often and put in the section view. The front is still going to give me everything like height and width, right? And I can even get the hole nice and clear now, where before the hole was a hidden geometry, right? So in a section view, the hole shows up because we've sliced through it and we're looking this way. We're looking the same direction as the arrows in your cutting plane. So if you put your arrows this way, then you're looking that way. That's why the hole shows up as a hole. Does that make sense? If you pointed the arrows the other way, then you would not see this geometry. So it's really handy for pulling out internal geometry that you just will not get to from a front, top, and a side view. Yeah.
I see why the arrows have involved in the first little object with the second object.
Here.
That's what really matters. Like all.
Which way you went? No, it doesn't matter. So here they drew it. I don't know why they called it a top view. I wish they would have called it a front view. Because they should have. This is a front view, right? It's pointing to the front. So then this is the section view. So that's just putting your cutting plane on a different view. That's fine. You can put your cutting plane on any view you want to get the section you want, right? And then they pointed the arrows this way, which means, okay, they're just looking to that side, but both sides would be exactly the same. Yeah, so it would not matter, which is what you're saying, right, Ben? You do. You got to put the arrows on and you got to point. Yeah, got to have them. So notice that they used, sorry, excuse me. They used 2 different line types for the cutting plane, right? This is like a big, thick dashed. So it is supposed to be the thickest line on the drawing, the cutting plane line, even thicker than visible lines. But if this is dashed, they're big dashes though. So that's okay for cutting plane line, or phantom, which is the 2 dashes and then a long, and it's called a phantom line. So that's okay also for a cutting plane line. Either one works. Use whatever you want. Pretty rare that you use a center line like that. That's not good. And then this break here, that's not good. Like use this or this. I don't know why they use the center line. It's kind of different. This is good, right? It's the big dash line for section BB. And we do label them. They're labeled on each arrow, AA, BB, CC. And then when you label the drawing, you call it out as section AA, section BB. Sometimes you'll see 3, 4, 5 sections on a drawing. And that's just so we can see inside the part. Like you'll see front, top, side view and section AA, section BB, section CC, and it's just giving you a view inside to the guts. All right, good. It's pretty straightforward. The section view often replaces a view, like top view, section view. Done. Got whatever geometry you needed. This one's front view, section view, instead of a top view, right? So that's it. That's what we're going to do. So what we have to be able to do is put in this hatching. So the hatching goes in where the cutting plane actually cuts the part. So if it doesn't cut anything like in here, it didn't cut anything in this hole, right? It didn't cut anything. That was air. So there is no hatch here. Here, the only place that it cut, right, was here, this geometry, because it's air here and it's air here. So that's the only spot that gets hatched, is where the knife actually cuts through material. Okay, so it's a puzzle for you to figure out. Like this one, right? Let's look at section AA. That's this full section here, all the way through. So it's definitely cutting in this region, and it's cutting in this region, but in the middle, it's just all air. There's nothing to cut. So the hatching only goes in where the material is. Have you hatched before in AutoCAD? Yeah, been a while though. No. All right, let's do it. Let's go with a new share. Oh, wait a second. Before I do that, what you're gonna do before I go into that, I'll just show you. You're going to create a section view of 2 pieces, and the 2 pieces are right here. I called them practice problems, but it's this one and this one. And I did make copies for you. They're over here. But before I go to, yeah, if you want to grab one, now might be a good time, because I want to go through the dimensions. Make sure you have. All right, let's look at this one first. So this one, the top one, it's called out as metric. So you need to make that one metric. So I think I said both of them were metric. So you might make a note on that they're both metric. That means you should be able to put both of these drawings in one file, right? You open up your metric template. You're going to use size A layout. You might want to delete size B and then just make another size A layout. You can put both drawings in one file. Does that make sense? Yeah. Okay. All right. Any questions on this dimensioning? On this top one? Huh? Yep, it's in millimeters. Everyone knows what the 2 times means? 2 locations is what that means. And so it's the 2 obvious locations that look the same. This one and this one. So notice this radius here, the 17, is to the outer curve, right? What about this one up here? What is that? It's diameter, yep. Why is there 2 of them? Exactly.
The outer circle first.
Nope. Good idea, though. Nope. Notice how close the size is to each other. Yeah, it's super small. It's a tolerance. So for no, it's really, those are really close together number. It's only a few hundredths apart, right? So that's for the manufacturer. Whoever's building it, they have to keep that hole between that range of numbers. From 4117 to 4128, and the part is good. So if you just list one measurement and hand it to a machinist, they're going to try and nail that. And they could spend hours trying to get it that accurate. If you give them a range and it's a hole, they'll shoot for the smaller number, right? If they miss it a little, they remove too much material, it might still be within the region. Much faster process, cheaper. Money is what the difference is. Yep. So here's the deal. When you draw it though, what do you think you draw it to? Which number? Because you can't draw it to two numbers, right? For a hole, the smallest number. So we call it maximum material condition, which means for a hole, you want to draw it the smallest. So then if somebody were to actually measure it, which they should never do, they would make it towards the smaller number, not the larger, right? Because if they miss the larger number and they go over, yeah, it's scrapped. It's a waste of time. So anything that's a hole or you're removing material, you draw it to the smallest. If it's something different, which we don't have any others, but if it's like, sometimes you just get an overall measurement and that'll have a tolerance to it. That one you'd want to draw at the biggest number. So if you miss, it ends up a little smaller, maybe it still works, type of thing. But anyway, yeah, you draw this one at that smaller number. All right, very good. Everyone knows what the diameter symbol is. We got that. R is for radius. I think we're good. Let's look at the second one. Yeah. No, we're not doing 3D. The section view was not 3D. It was 2D. Right? So let's go back to that. Oops, missed. So here's your examples. This is what's given to you. This is what you're drawing. A view with a cutting plane line and then a section view. You're not drawing this. That's just how the object's given to you. It's like a real object in real life, right? If I was going to draw this coffee cup, I have the coffee cup, but I'm going to make a flat plane, two-dimensional drawing. All right. Good question. Good question. Good question. All right, let's go to one more. Let's make sure we understand the dimensioning on the next one. All right, any questions on this one? I think it's all pretty straightforward. I don't see any tolerances. Just be careful on, where the dimensions come from. This comes from a false corner right here. That's all supposed to be straight, but it's coming from right there, and that corner actually doesn't exist, right? So just be careful where the dimensions come from. Try to look carefully at that. Notice this R35 comes from the top, this 64 number comes down, and then that's where the radius is swung. So yeah, just look at it carefully when you go to draw it. Try and pick out those dimensions. I hope they all add up. There's a few of these drawings where the dimensions like literally do not add up, which is not good. So if you come across one, just make an assumption and go for it and just put a note on the drawing. Yep. Yeah, so we're going to talk about that. I want full sections. So I want this cut, but I'm going to draw it with the overhead here. So let me get that going. All right, so for this one, I'm going to have you do a full section this way. And you can, I don't care which side you look at, they're both going to be the same, but we're picking up this hole, right? So full section, kind of like that one example, which is not the long side of the object, but it's the shorter side of the object. On that one. And then this one, I want a full section through its length. So full section is going to be all the way through. And again, it's not going to matter which way you do it, but it's going to come all the way out and past. So what you have to do is you have to draw the top view first. I'm just going to rough it in. It's not going to be complete, right? But this would be the top view. There's some holes here. There are some chopped off corners here. It's not very complicated. There's some hidden geometry in the top view. That's all good, right? Everybody with me? So that's what you'll do, is draw the top view first, and then the cutting plane goes in this view. Like that. And then you can draw the section view up in here, or down here in place of the front view, and this will become section. You know, if this was A and A, and if you draw it. So that's what we're going to end up with. Once we get that section view done, then we can hatch it in, right? Everywhere the knife cuts turns into a hatch. All right, so let's look at, I think I'll work with this one in AutoCAD, not that one. And just start it, whoops, stop share, new share. And then you can go from there. I'm going to start a new drawing because I need it to be metric. You should, absolutely. You're going to need it's got to be in a layout with a title block. Everything from here on out is with title block. So they're both metric, so you can put them both in the same file. Yep. I want a size, so yeah, does kind of matter. A size paper. So that was the first thing I'm going to do. All right, get the grid off. I didn't bring any layouts, right? But I have two layouts that are in here, and you just would want to modify your second one or just get rid of it because we don't need the B size. We just need the A size, right? So once you come into a drawing, you can do whatever you want to the layouts, right? So the other thing you can do is you can right-click on the layout and copy it. So then you have two A size, right? So that's what I would do, is go in. There's a little create copy button right here. Like, took me a while to find that one the first time I did this. I say, okay, and it'll just create a copy of it. And then you already know you can rename them. I'd probably rename them the name of the part. Like one I would call bearing. And one I would call rod support. Right, so now I have my two layouts. If you use your template, the title blocks will be there for you, ready to go, right? I didn't use a template, so I don't have that feature, but I still wanted to show you just the basics of doing two drawings in, give me a break, one file. So now in here, I can make one drawing, and then I can make another drawing kind of off to the side, right? So here's my two drawings. When I come into rod support, I can zoom back set my scale, make this drawing. Right? So that's rod support. And then in bearing, I can zoom back, find the bearing drawing, bring it in, set my scale. And now I have two drawings going in one file, right? But in model space, it just looks like two drawings. You just need them far enough apart to where you can bring them into your viewports and do whatever you need to do. Good? So that'll be kind of new, two drawings in one file. Good practice. I'm gonna draw out this thing a little bit, just a little top view, not gonna be complete, but what's the overall length of this thing? 113. So I'll go line and just aim 113. 113 millimeters is pretty small. So then it looks like it goes up. How far? 13. Then it comes over. Do we have an over? Yep, 25. Yeah, A size for both. Oh, I'm drawing the front view. I want the top view, so I'm scratching this. Sorry. How deep is this thing? 32? Yeah. So I'll just get the kind of the overall here. Using my O snaps. I'll use offset and offset these vertical lines. Looked like it was 25 from here to here. The offset just gives you a copy at a distance. So I can do that again at 19 here to here. It looks like it's 25 in the middle from here to here, and then 19 again. And I'm just using the space bar to bring back the last command. It's pretty fast. So then I do have some holes to put in. I'll offset 13, and that's, according to this, that's where the hole belongs, from the back. So I'm just gonna make sure I did that right. Because it should look like it's in the middle. 13. Oh, that's better. It's not in the middle. Doesn't look like it, right? Everyone see where I'm getting that? 13 from that back. So it's not in the middle. So now where is it located? Side to side? Does it give it to us? Where do you see that? Oh, on the very, I see a 13 in from the back. Here. Oh, I see it. Nice job. Offset. I do this a lot. 13. I'm gonna offset adding. And now I know this, the circle goes right there at that intersection, right? And how big is that circle? 11 diameter. So 5.5 radius. Yeah, everybody see that? Looks bigger than what they show. So these are not always perfectly to scale, for sure. Just be careful with your measurements. Offset. 13 should still be going over there. And then I'm going to do a copy this thing from here to here. All right. When you do that, you use construction lines, just make sure you get them out of there because they really confuse things. All right, that's good enough. There is some hidden geometry in here, and I have corners to chop off. I get that, but I want to do the section part because it's a little tricky to make the cutting plane line. Like, you want to make a line that has arrows on it. That's a little trick, okay? And AutoCAD has no easy, fancy way to do it. You can use a line type that will work for the cutting plane. So that's what I'm going to do. So the way I do that is I literally just put the line in. So I'm going to come out here, put the line in, kind of where I want it. And then I'm going to change the line type to something I want. So I grip it. I go up to probably properties. Yeah, it's not going to work. I'll go to line types right here. It's not loaded, so I have to load it. Maybe in your template, it'll already be loaded, right? So I'm going to load. I'm going to look for Phantom. I don't know that the ISOs have, I could use Dash, that'd be fine. See what I get. ISO Dash. So now I'm gonna change it to that, because that should be loaded. I like it. It looks good. I like it. Yeah. Yeah. Nope. I want to pick up those circles perfectly. You can put that cutting plane anywhere you want. Like if there was more geometry here, you can actually offset the cutting plane line. That's called an offset section. We're not doing that. We're just doing straight cuts, but yeah, you can pick up any geometry you want. So I want these circles. Okay. So then I could give this line thickness because it's supposed to be a good thick line. That's here. Right? And I'll just go down to something 0.35. So I'll go there and 0.35. So now, huh? Yeah, it really should. Thickest line in the drawing. For the visibles, yeah, then you got to go thicker. So just make sure you can do that. You can do that. All you really want is a clear difference. But definitely go into the layout to look at it because it'll look different in layout. Like look at my dash lines in layout. So that could be just a regen. I'll see if that is. Yeah, it is. So I just regen. I type in regen, hit enter, and it shows me what it's going to look like. Notice there's no line thickness yet. What are you doing, Ben? You wandering around the class? We're not on that one. We're on this one. I'm ready. What?
So this is 14 diameter, right? 14 millimeters. And this entire thing right here
It's 17 radius.
is okay.
That's a diameter radius. So this is what? 34 diameter. It's
Yeah.
huge.
Wait, what?
You know the difference between radius and diameter?
Oh,
Yeah.
whoa.
Yeah. That's what you're missing there.
Ah.
All right. So here's the deal. This is a thick line because when I grip it, it shows up as a thick line, but it's not showing up. So if you want your line weight to show up, there's a quick button down here. At least there used to be. That's not it. That's not it. That's not it. I don't see it. You can always type in line weight. And I think it's LWT is the shortcut. But if you do that, you can see that there's a display button. And it's not toggled on. If I toggle it on and say, okay, then that's supposed to turn it on. Now it maybe did. It doesn't look like it did. Try that again. LWT. Doesn't like it. Maybe I didn't say. I did. I said, okay. And it's on 35. I don't know why it's not showing up. Sure should.
Incorporate into a template.
Yep, absolutely. Anything that we do. Yeah, yeah, or you can change your template as you go. Just add to it. Resave.
Like if I, so say something like this, I'm still drawing.
Yeah.
And I do a thing, setting,
Yep.
and save that as a template without including the drawing, right? If the drawing would be in the template.
Right. Right.
But actually, for starters, it might not be a bad idea to just keep doing that.
Yeah.
And then
You can do that and then just erase the drawing out of there and resave. Yeah. All right, so here's the next part that's a little bit tricky. And that's getting these arrows on. So you don't really want to use leader. That's always going to be a very small arrow. So I have to actually teach you polyline so you can make an arrow. So polyline, they're wide lines. And you can control the width. So you can make a line have a varying width, like an arrowhead, right? So instead of line, it's PL for polyline, P line. And you start it just like a normal line and you start drawing. And it's giving me line thickness because I have line thickness here. But I can also give myself line thickness because you have all these options to polyline. Arc, half width, length, undo, and width. So you can set the width. So I'll type in W. And my starting width, I'll make, did I place line? I didn't. Here, let me go polyline. I'm gonna do that again. I'm just gonna set the line first. Now I'm gonna make the arrowhead. So I just made a little line first. And I'm gonna go W. So starting with, you have to think about like how big you want your arrowhead. I don't know, maybe 5, 6, 8 millimeters. I'll go 8 millimeters. And then how the ending width is. So you get a start and ending width. So 8's the start. I'm going to end with 0 because I want it to go to a point. And now you'll see it and I can draw. All right, so maybe 8 millimeters was a little big, but you get the point. It might not look bad in here. It looks pretty bad. Okay, I'll show you. So you got to type in PL, enter, and that, you have to hit your start point before you get options. You do have to hit your start point. So PL, no options. No. So boom, and then again, and it should stay. Just asking for next point, next point, next point, next point. So do PL start and then pick a spot. If it's available. Yep, W. Yeah, but look down at the command line. Specify the starting width. So I'm going to go much smaller this time. I'm going to go 4 millimeters. And I'm going to go to 0. And then as I drag it away, that's looking better. And then I would go to layout to check it out. Yeah, that one's looking better. You didn't put in an ending width. So it's going to prompt you for a start width and an ending width. And the ending width's got to be 0. Yeah. Yep, yep. And when you move your mouse, it'll start making the arrow. Yep. And honestly, once you get one done, you can just copy it. You don't have to keep making these things. So there is, but I'm not going to go there. Yeah, there's an ANSI standard for absolutely everything. But so it looks good would be what I would say. Like that first one did not look good. That's too huge. This actually looks pretty good. Like when I zoom in, it's still not too obnoxious, but you do want it to jump out at whoever's using your drawing. Yeah. Yeah. Yep. Yep. Yep.
But is there a way?
You can put in a dimension for that drag. Yeah, but I wouldn't. This is what I'd do is I'd pick the one I liked and just go copy. Right. And then take it and set it over here. Now I have them exactly the same. Yeah. And if I needed more, I would just keep copying them, rotate them. Once you're happy, then you don't have to use polyline. All right. So then let's do, and I'm just going to draw I'm not going to draw the side view, but I'm going to draw just a rectangle
Just front view and.
Section, yep, that's it. Yep. I'm gonna get rid of the thickness of the line for now. And then I'll just. All right, so if I wanted this hatched, this area, right? The easiest, I don't know where, oh, is this hatch? Yeah, this looks like hatch. Yeah, so the easiest is boundary hatch. So to type it, it's B hatch, right? And if, again, if you don't know how something works, just leave your mouse on it, it'll tell you about it, but I'm gonna click boundary hatch. Picking points is the way to do it. That's how you identify the region you want. So picking points is already chosen. And you just pick in here and it's gonna find that boundary for you, right? So this works if it's a simple area. If it's complicated in a complicated drawing, boundary has a hard time determining what the heck the boundary is, right? Yeah, then you have to actually pick it out. Yeah, you have to pick points. And then if you want, like, if there's text in there or dimensions and you want those not to be hatched over, you have to choose those. Like if I had, let's see here. If I can just place something in here. Yeah. So if I had text in here and I wanted it to not be hatched over, I'd have to choose it. So boundary hatch sometimes will find that for you. See what it does. Yeah, it didn't find it. So it's going to hatch right over that. Right. So then the other way is just regular pick points. If you just go into hatch, you get the hatch selection area. Right. And then pick points is here, but select is here. So I could go select this, 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 and that. Right. And it gets super confused. That's because these lines were long. Right. And it picked them. So undo that. I would have to chop these lines off to do it that way. That makes sense? I think you can combine. Let's see if we can combine. So can I go pick points here? Oh, it found it, I think. That time it found it. It's highlighted. So that's good. Huh? It's just the default hatch that's being used. You can choose your pattern. So here's ANSI 31. That's what we typically use. So ANSI 31 is the common hatch. I think I'm still on thick lines, so that's why I'm getting thick lines. So I'm gonna undo that. Get rid of that. And go for it again, hatch. I'll use pick points. It found it again. I'll go to ANSI 31. And then there's scale. So not all drawings, that might be too small or too big. If you had a big drawing, that'd be too small. You want it to show up, but you don't want it to be super tight, right? So there's a scale, hatch pattern scale right there. So if I went to 3, it's going to change that. Oh, this is metric, so it's not going to change it much. Yeah, so there's that scale. That's like a 10 scale. If you want to edit it, you just 2-click on the hatch and it brings it all back. So I'll go back to 1 scale. Let's see what 0.5, you can go down. So 0.5 scale's really tight. 1 actually looked pretty good. And when you like it and you're happy, you just hit close hatch editor. Don't hatch and then erase it, hatch, erase it, because all that stays in the file. If you're gonna remove your hatch, undo it. that removes it from the file. Okay. There's other hatches, just since we're doing hatch. There's solid hatches right here. So you can make like a solid color instead of lines. And then there's all kinds of patterns, like you can scroll through them, but there's many patterns, right? On and on and on and on. Lots of, you can do stars, you can do all kinds of goofy stuff. So we just want ANSI 31. That's the normal. You can change the angle. Like the reason we would do that is if this needed to be hatched, but it was like copper and this was like steel, you would use a different hatch pattern for a different material. Yeah, yeah. So maybe not in metric. There's earth. There's gravel. Yeah, I don't see it in the metric, but when you're in the US, you'll see specific hatch patterns. They've kind of gone away from it. It was really cool in the beginning, and then it became just like too complicated. Instead, now we just make them different for different materials, and then you'll call out the material. So, but if I wanted it different for this one, so I might go hatch, pick points here. It's on solid. I'll go to 31. It's on 10. I'll go back to 1. Right? And then I'll change the angle. 90. So it's 90 degrees from where it was. It was at 45, so it just goes 90 from that. Close. So that's how you do it if they were dissimilar materials, but you still cut through them. So, all right. I think that's good, unless you got questions. Full sections. Huh? Okay, I can show you that. So the only way you can't change it once you start. Yeah, no, you can't change it. So the only way to change it is to start a new drawing, go new, and then choose the ISO version of your template or AutoCAD's ISO version for metric. That's the only way to do it. Yep. Yep. Yeah, it won't tell you what you're in. It'll tell you the units for inserted content. So like if you're bringing something in like a block, we haven't done blocks yet, but a block from someone else, and you know theirs is metric, but you're in US, then you can insert it in a specific unit. But you can't change the unit of the drawing. Yeah, it's good to know. No way to do it. What you can actually do is you can scale your drawing. So if you draw something in US and you want it in millimeters, you got to scale it by 25.4, smaller, but it's still going to be in inches. Like when you go to dimension it, it's going to dimension it really small then in inches. What I would do is scale it, copy it, and then move it into a metric drawing. And then it would be metric. And we'll actually talk about how to do that when we get there. But yeah, for now, just try to remember, start in ISO if you're metric. Yeah. All right. That's it. Lab time.